Hi, I'm an old guy and I do maths, and today we're looking to unravel this. What exactly is it and how do we understand it? Well, um, where are you going to see this first, I guess? In a number of places. The two that spring to mind where you have probability density functions, and the other might be when you're first looking at calculus and the question of continuity is raised. Basically, you can't differentiate a discontinuous function, certainly not over the area of the discontinuity. Get that word out. So what do we see here? Well, we see a function that has three parts to it. But if we look closely at these elements, what we see is that this function of x is equal to 0 where x is less than 0. Okay, fine. When x is equal to or greater than 0 but less than 2, function of x is equal to x over 2. And x is again equal to, function of x is again equal to 0 where x is greater than or equal to 2. So there isn't a discontinuity here. What there is a series of phases in which this function behaves differently. So you can see in the bottom of the picture there's a hint of a Cartesian plane, and I'm going to draw in red as best I can this function. So below 0, where x is less than 0, the value of this function is 0. So what I want you to pretend is that this red line is actually on the x-axis, but I want you to be able to see that. Where x is equal to or greater than 0 but less than 2, this is a linear function, a half x. So if we plot the value of that here, what we get is we get a point there, 2, 1 would be our point. And this function does this. And beyond that, this function does the following. Now, because this is most likely, I can't remember where I found this, but it's most likely that this has something to do with a probability density function. What we're interested in is this part of the function. And a quick calculation will tell you that the area between the x-axis and this line here, between 0 and 2, is 1. Height times base divided by 2, simple triangle. So height is 1, times 2 is 2, divided by 2 is 1. So that tells me that I probably found this when I was fishing about in probability. Anyway, this translates to this. Now, let's just say that we changed this in one respect. We made that 1. What we would get is the following. And I'll put this in blue. So we would have a function of sorts without any break like we have here, any gap down, and so we could have something that looks like that. Let's try something else. Let's change this to negative x. Our function would now look like this. So really all that this is about, and how you read this, is as the same function that behaves differently between certain parameters, or above or below certain parameters. And while this started off as pretty simple, there was only one point where you actually had to calculate the value of the function, and that was between 0 and 2. Everything else was just 0. You can have functions of this nature that look like this. They can contain quadratics, cubics, anything at all. There's no limit on them, but this is how you read them, and this is how you represent them on a graph. Now, I hope that this was useful. I hope it eased some confusion. If it did, please like and subscribe, and I'll see you next time. Bye.